Well, today we're going to talk about hypothesis testing. So our objectives are talking about hypotheses, which are educated guess and hypothesis testing. When we are making claims about population parameter, it means that we are dealing with statistical hypotheses. So statements about a population parameter. Population parameters like the mean, like the standard deviation, like the proportion, and so on are statistical hypotheses. We make a statement about population parameter if it includes equality, equal to, less than equal to, greater than equal to. It means that you're dealing with null hypothesis. Null hypothesis, which is denoted by H sub 0, null hypothesis, is a statement that includes equality. Equal to, less than equal to, or greater than equal to. The alternative hypothesis is the complement of null hypothesis. Alternative hypothesis, which is denoted by H sub A, is the complement of null hypothesis. So what is the opposite or complement of equal to? The opposite or complement of equal to is not equal to. What is the complement of less than or equal to? It's going to be just greater than. And what's the complement of greater than or equal to? Is less than. So when you're constructing null hypothesis, alternative hypothesis, we read the statement carefully. We identify keywords. Then, based on those keywords, we construct a null hypothesis or alternative hypothesis. So note that when we read an example or a question, we need to identify keywords. Keywords equal to, is, less than or equal to, greater than or equal to. They are not equal, greater than, or less than. After identifying the keywords, which are is, equal to, at most, less than or equal to, least, or greater than equal to, or keywords like they are not the same, not equal, more than, greater than. Less than. and so on. Based on those keywords, we construct the null hypothesis or alternative hypothesis. So when you read an example or a question, we need to identify the keywords. These are the keywords. Then we construct either the null hypothesis and alternative hypothesis. Well, suppose you have information about population parameter or mean, proportion, standard deviation. We have different scenarios, different categories. So suppose you have information about population parameter and it's related to the proportion. Hypothesis testing for proportion. We can categorize hypothesis testing for population proportion this way. The first category, or case 1, can be written this way. The null hypothesis can be asserted this way. The population proportion P is equal to a number like L. Its complement is alternative hypothesis, which says population proportion is not equal to L. L is just a number. This is your first case. This is your case number 1. The second case in hypothesis testing is that when you're reading a question, you have information about less than or equal to or greater than. The null hypothesis says population proportion is less than or equal to L. Its complement, alternative hypothesis, the population proportion is greater than L. And the last case, case 3, when you read a question, you might have information about null hypothesis by saying that greater than equal to is mentioned in the question, or you see less than. So in this case, the null hypothesis can be written as P, the population proportion, is greater than equals to a number. Alternative hypothesis, population proportion is less than that number. Hypothesis testing for population proportion. P represents the population proportion and L is just a number. So another case that we're going to talk later is hypothesis testing for population mean. The mathematical symbol that we're going to use for the population mean, remember that it's denoted by Greek letter mu. So our case 1, the very first case, is null hypothesis says the population mean mu is equal to a number like k. Its complement, alternative hypothesis, the population proportion is not the same as k. The second case, case 2, alternative hypothesis. When you read the question, you have, for example, information about the alternative hypothesis or null hypothesis. Suppose the information about null hypothesis can be identified in the question, and its mu, the mean of population, is less than or equal to k, so its complement can be written as mu is greater than k. Third case. Information about null hypothesis or alternative hypothesis is given in the question. And suppose your null hypothesis says mean is greater than equals to k, and its complement can be written as mean less than k. In our note, we have a very nice table representing the verbal statement and the mathematical statement, both for null hypothesis and alternative hypothesis. Again, when we read an example or a question, you might have information about null hypothesis, or only information about alternative hypothesis are given in that example or in the question. Our job is to identify those keywords and then write down our null or alternative hypothesis. If the keyword is greater than or equal to, it means that our null hypothesis is given. If the keyword is at least, the null hypothesis is given. Not less than, it is equivalent to our null hypothesis. But if the keyword is just less than, there is no equality in less than. It just says it is smaller than, less than. It means that our alternative hypothesis is given. Below k, equivalent to alternative hypothesis. Fewer than k is equivalent to alternative hypothesis. Again, take a look at the board. This is our very first case. Our second case, and finally, the third case. All of these are listed, and the table there gives you the keyword for each of these. So when it comes to hypothesis testing, we might have the chance of making errors. Some errors are serious, some others are not that much. So we have type 1 error and type 2 error. We can summarize type 1 and type 2 error this way, which is very helpful to remember these types of errors. So we have our null hypothesis, and we have the type of error that we have. So here you have a decision about your statement, and here you have the truthness of your null hypothesis. It's either true or it is false. So let's write down the decision here. We decide to reject the null hypothesis or fail to reject the null hypothesis. So reject the null hypothesis, or we decide to not reject it. Fail to reject the null hypothesis. Well, if your null hypothesis is true, but you reject the null hypothesis, we have type 1 error. So null hypothesis is true, but you will reject it is called type 1 error. If null hypothesis is false, but we fail to reject the null hypothesis, we call it type 2 error. In either of these cases, you make a correct decision. What's the meaning of that? The null hypothesis is true and we fail to reject it. So it's a correct decision. If the null hypothesis is false and we reject it, again, this is a correct decision. Let's take a look at one quick example to understand how we can use this nice table and identify type 1, type 2 error, and which one is more serious. So in this example, we have the following. The USDA limit for salmonella contamination for chicken is 20%. So let's just circle this number. The limit is 20%. A meat inspector reports that the chicken produced by a company exceeds, the keyword, exceeds the USDA limit. You perform a hypothesis test to determine whether the meat inspector's claim is true or not. When will a type 1 or type 2 error occur? Which error is more serious? So these are the information that we have here. We know that the limit is 20%. Now we're looking for a statement about hypothesis to construct the hypothesis testing. First of all, what's the meaning of exceeds? Exceeds, it means that it is greater than. So greater than, the mathematical symbol is greater than. The inspector reports that the chicken produced by the company exceeds the USDA limit. It means that the proportion is greater than 20%. The proportion is larger than 20%. Since we have greater than or larger than, there is no equality here. It means that this is equivalent to our alternative hypothesis. So alternative hypothesis says P, or population proportion, is larger than 20%. In this example, we have information about alternative hypothesis. Again, inspector reports that the chicken produced by a company exceeds the contamination. The limit is 20%, so the proportion is larger than 20%. Since we don't have any equality, it's not greater than or equal to, it is just exceeds. The interpretation of exceeds is greater than, larger than, mathematical symbol, larger than. So we have our alternative hypothesis, P, or population proportion, is greater than 20%. Now that we have information about alternative hypothesis, we can quickly write the null hypothesis. The null hypothesis is going to be the complement P is less than or equal to 20%. Very well. Now let us analyze type 1 and type 2 error. Let us form our table. Truthness about our null hypothesis, and here we have our decision. Your null hypothesis is either true or your null hypothesis is false. The contamination, the limit of contamination, is less than or equals to 20% or it is not. The decision that you make is either reject the null hypothesis or fail to reject the null hypothesis. Okay, what's the meaning of these? Null hypothesis is true. The contamination limit is less than or equal to 20%. So P is less than equals to 20%. And you fail to reject the null hypothesis. It means that it's a correct decision. But what if the level of contamination is less than equals to 20%, but you rejected the null hypothesis? It means that we made a mistake. There is an error, and this is type 1 error. In this error, you have the following. You have a chicken, and the level of contamination is less than equals to 20%, but you reject the chicken. So you made a mistake. The chicken is healthy. You have a healthy chicken, but we reject it. What if your null hypothesis is false? What's the meaning of that? It means that the level of contamination is not less than equals to 20%. And you fail to reject it. So P is not less than equals to 20%. And you fail to reject that chicken. The level of contamination is higher than 20%. But you fail to reject it. You didn't reject the chicken. It is type 2 error. This error is serious because you have a sick chicken and then you decide that, hey, it's a healthy chicken. So it might get into the market and people get sick. So this is serious. However, if the level of contamination is not less than equals to 20%, it means that it is larger than 20%. and you reject that sick chicken. You reject it. So of course it's a correct decision. So type 2 error is more serious than type 1 error. In type 1 error, you made a mistake. The level of contamination is less than equals to 20%. It means that the chicken is healthy, but you made a mistake and claim that, hey, the chicken is not healthy. And you threw the chicken away. You might hurt the cell. You might hurt the cell, but you're not hurting people's safety and health. So if you make type 2 error, if you have an unhealthy chicken and you decide that, hey, the chicken is healthy, it might get into market and it's dangerous to people's safety and health. So this is more serious than type 1 error. Type 2 error is more serious than type 1 error. More definitions. When you are dealing with hypothesis testing, you're interested in level of significance and p-value. So the level of significance is defined as the maximum allowable probability of making type 1 error. Is the maximum allowable probability of making type 1 error. It's denoted by alpha. P-value, so this is the level of significance, and p-value or probability value. P-value, if the null hypothesis is true, p-value is the probability of obtaining a sample statistic. You have a sample, you find the, for example, if you're dealing with the population proportion, you're finding the sample statistic, sample proportion. If you're dealing with the, for example, the mean of the population, your sample statistic is the average of the sample and so on. So if your null hypothesis is true, then the probability of obtaining a sample statistic as extreme or more extreme than the one given in the example or question. is called the p-value. For probability value.